Hi everyone, this is a video about um, solving the longitude problem by experiment. Solving the longitude problem statement. Why it was easy to find location between North Pole and South Pole, one had a tough time finding the location with respect to Greenwich time zone. For those who get confused between latitude and longitude, that includes me. So that's why I've said Greenwich time zone instead of longitude, whether it's longitude or latitude. Solved by using time zone. So your noon clock compared to Greenwich noon clock time. So um, if it is midnight uh, in your location and the Greenwich clock says midday, then you're 360 degrees up, you're 180 degrees apart. So it took me a lot of time to figure that out. So I put three OKs here. So the approach presented here can solve the longitude problem as well as the latitude problem. Modern systems use GPS. Spoiler alert, don't continue to watch if you work on this problem, and if you don't want to others to interfere with your thought process. Hypothetical solution. Solution proposed is a hypothetical solution, meaning it may never work. Relies on changing g-force based on several factors. Apparatus. So this is a symbolic representation of apparatus and all the features it has. So it has a vertical stick, and it is going to fall down, and as it falls down, it can rotate about a vertical axis along the horizontal plane, and it has a mass at the top. That mass can move up and down, increasing the length of the stick. uh, the mass can be varied. The mass can be a gyroscope at the top, and these two are rotation amplification measurement devices, and this is the increase and decreasing length of the stick as it falls. Again, a measurement system, and the clock that is required to time the fall, and these represent the repetitions. So if we make the stick fall 5 times, 10 times, 50 times, so to amplify the difference in measurements at different locations. Uh, and look at this, like I was impressed by the gradient color I could get from Microsoft drawing tools, and I just want to make a point about that. Okay, now the plan is rotating and falling stick depends on acceleration due to gravity, variation of gravity at various locations, stick length, mass at the top of stick length, gyroscopic effect of falling mass at the top of stick rotation due to centrifugal force on the stick due to earth rotation, stick movement due to movement of earth, variation of acceleration due to gravity with respect to moon and earth. So thus this falling stick is sensitive enough to pick the location of moon and sun. Air resistance, stick elongation due to centrifugal effect of stick rotation, stick elongation due to centrifugal effect of earth. Because stick is falling, and earth is rotating, and that can have an effect. Time to fall, latitude and longitude, initial inclination. So tilt can be towards or away from the vertical. The vertical can be gravitation from found by gravitational method, or it can be found by astronomical method. I put a question mark because I don't know. I'm not a, seaman or a navigator, so I've read that there are tools that can do that. Cumulative data based on repetition. So if two people run 100 meters and that's a small difference, but if uh, they do the 100 meters 10,000 times, the difference can be may or may not be noticeable. Simple registration, data registration tools. This is the varying the radius of the sliding channel. I will explain this in the later slides. This particular point. Procedure. Following the procedure I implemented when performing the study. Perform the expert various latitudes and longitudes. Good place would be where there is a telescope, a place where there is a higher educational degree offering uh, e- uh, uh, education system. Register observers under various conditions that are presented. Produce procedure can be implemented for any set of observers and underlying factor studies. So the procedure that is described, a simple procedure, can be implemented to find cause and effect relationships. Measurement. So this is again the measurement amplification this system that I have put here, and scalar measurements. So modulus scalar distance. Modulus scalar is distance measured on a vehicle. Uh, such a such a measurement is used can be used for fuel efficiency. So more non-modulus scalar is has positive and negative and values and can go even though the total distance traveled may not be zero, the distance traveled can be indicated as zero. So vector measurements, this is obvious. So I have not explained it. So scalar array measurements, cumulative scalar array measurements, cumulative modulus scalar array measurements. So for example, 4, 3 minus 4, 7 minus 2 can be as reported as cumulative scalar array measurement as 8. So that sums to 8. Uh, Cumulative modulus scalar array asset measurements is 14 and minus 6. So for the apparatus that is mentioned, this kind of separation is important because you may also want to know how much maximum displacement was there in each direction. So multi-dimensional vector, because so this again because we are doing the uh, measurements repeatedly and the direction of the uh, factors and the observables can change. Multidimensional vector array measurements, cumulative multidimensional vector array measurements, cumulative modulus multidimensional vector array measurements. Example: 4 east, 3 west, 5 north, 6 south. Cumulative multidimensional vector array measurements is will lead to 2 west and -1 south. Cumulative multidimensional modulus vector array measurements would lead to 4 east, 5 north, 6 south, 6 west. So these are important for certain types of repetitive experiments where you may want the modulus form and non-modulus form of the data. Hypothetical results. Plot shows change observers due to change in factors. So assume that this is observable on the y-axis and these are the factors under which the experiment is carried out. So this such a simple tool can have dependence, can be used for dependency studies. So in this first set, there is a clear difference that is noticeable, and in the other set, the factors don't seem to play a role. For instance, you as an experiment you want to have a difference, but in some situations, not having a difference is good. For instance, if you are uh, detecting dark matter studies and you actually don't want to, even though you want the instrument to work perfectly, but you don't want to see any dark matter that you can't that can be detected by gravitational measuring gravitational forces. So problem motivation. The English movie The Edge, where someone is lost in the dust in the forest and finds magnetic north by placing a charged charged pin on a floating leaf. So that lets the authors think that floating sticks should fall differently in different reference frames. In northern hemisphere should fall south, in southern hemisphere should fall north. Viewed about ship navigation problems because of longitude calculation. So there are supposed to be longitude calculation problems because of ship navigation. So author doesn't know whether the quoted is true or false. You may find do the experiment and find the quote to be false, but that could be error in your experiment because you might be using gravitational vertical instead of uh, geodesic vertical. So geodesic vertical and gravitational vertical can vary different parts of the planet. Future work. So this is a change in apparatus where the base of the apparatus is allowed to slide along a particular direction. Uh, Another is increasing the radius of the sliding object. So you can increase the torque that is transferred to the system by increasing the three different sliding slots. So you can actually do this separately to test whether whether changing the radius actually uh, increases the measuring ability of the rotation torque transferring system. So you can produce a torque as the object falls and see whether it causes a rotation in the vertical axis. And that rotation varies because based on the uh, direction of sliding slot. Another important thing is you can do these experiments in a floating apparatus. So this is a cylinder in which the apparatus is floating, and you can perform the study. So another similar study is Coriolis torque measurement apparatus. So this is the torque, and this is radius one. This is velocity at one extreme, one diagonal extreme, and this is velocity in another diagonal extreme. So these two velocities are different uh, because this apparatus is rotating in a frame. As the particle slides down the slot, it will change. It will cause forces in this apparatus and causing the apparatus to rotate. So this can be amplified and studied. This is the Coriolis torque measuring apparatus. Author does not know whether this has been implemented, or author does not know whether this is the exact mechanism by which it was implemented. So this is a very simple apparatus. So people might have implemented, people might not have implemented. Author is not aware. If you know something, let me know in the comments. Disclosure: author has read basic physics books and engineering degree, read about longitude problem and was solved by clocks. So yeah, that's a easy, simple way to solve the problem. So I talked about it. Ideas presented are author's own to the best of his knowledge. So it may, if it is reinvention, he wants reinvention credits. If you have read or seen similar works, let the author know in comments. Is the hypothesis going to work? Presented in yes or no? Let me know in the comments. Acknowledgement. Microsoft Corporation Computer Hardware Manufacturers Books. University of Physics. Sears Zemansky Young. Physics Volume 2. Resnick and Holiday. Problems in General Physics. I.E. Iridov. Introduction to Mechanics. Kepler and Co. If you enjoy the video, like like the video and share. Any information about the topic in the video, comment below. Author's own puzzle book Patterns is out, and if you are interested, uh, please buy the channel and show interest. Thanks a lot for your time.